Hey guys, so in this video, we're going to be going through the process of relative dating. It's a follow on from our fossil record video, and we're going to look at how we might date some fossils. So our learning intention for this video is to understand how we use relative dating to date fossils, to understand how we might use index fossils in relative dating, and to know some of the issues with relative dating. So fossils, we need to date them to understand where they fit in our fossil record. And there are two main processes that we use. One is known as relative dating, which is comparing the different layers of sediment or soil to where the fossil is found. And absolute dating is a complex process which gives us a very unique and very absolute date. We're going to cover that in a later video. So here we can see relative dating is a much more simplified version of dating fossils. So relative dating uses the idea that the rocks at the top of a rock profile, and sometimes it's called strata, are the newest and rocks at the bottom are the oldest. Okay. Now this assumption means that we can date fossils relative to one another. We can say which fossil is the youngest and which fossil is the oldest. Again, it's based on an assumption. But if we have a look at this diagram here, we might say that this skull is a lot younger than the fossil that looks like some fish bones. So that's purely what we can get out of that data. I can't tell exactly how old they are, but based off relative dating, I can definitely say that this one is a younger fossil compared to the one in the middle or even ones further down. Again, it's based off the assumption that the strata are in the correct order, but at least I can relatively date these fossils to one another. So for example, here again, we can see we've got layers A, B, C, and D. Based off the assumption of relative dating, we would say that D is the oldest fossil and A would be the youngest and B and C would be in between those two. Again, it's based off an assumption. So we can also then start to use fossils which we have a known age or ones that are commonly found in this distinct time period as index fossils. So here we can see we've got a skull fossil, and we can sort of date this to 45 million years ago. It's a known age. And so then if we were comparing two different sites, in this example in Montana versus Texas, we can see that, okay, well, this layer is 45 million years old. So we would assume that this one is roughly 45 million years old as well. Same with these bottom shells. You can see that these known fossils are around 100 million years old. So if I compared that rock strata or layer to this strata, we would say that they're roughly the same age. So we can use relative dating and index fossils to give us a somewhat accurate picture of when fossils may have existed, even if they're in different locations. Some of the issues with relative dating is that the date range we're looking at can be extremely large and the strata might span over millions of years. So obviously, the longer the span is, the less accurate our assumptions are going to be. Okay. We can also have the issue where the Earth's layers aren't always nice and neat in straight lines. And through things like tectonic plates and earthquake movements, we can see that using Earth layers might lead to inaccurate readings. I know looking at this picture, I couldn't tell if A or E was older or younger. And same with C, we can't really say as it spans over all the different rock strata. So there are some limitations of relative dating. So in review, it's a process which uses compare layers, known as strata, to compare different ages, and it assumes that the layers at the top are the youngest and vice versa. Okay. We can also then use index fossils to compare different layers or strata at different locations to get a picture of what age groups they may belong to. So I hope this video helped.